Introducing the team members of SafeLiCell from Maryland, a graduate student in chemical and biomolecular engineering, Erin Fisher, and a professor in bioengineering, Dr. Peter Kofinas.
On behalf of SafeLiCell, my name is Erin Fisher, and I'm here today to present on our lithium flex technology, which leads to safer lithium batteries. Right here, as you can see, we took a pretty standard lithium battery, lithium polymer battery. This could be in your cell phone, your laptop, and you put a bunch of these together. Maybe it could be your car. And we actually shorted it. We connected the positive and the negative terminals. Do I press play, or who's got play? All right, there we go. And so what we can see here is it started heating up. The casing actually started to go, and you'll see it. And we managed to catch it on fire pretty quickly. And why that doesn't happen to the laptop, the battery sitting right in your cell phone next to your pocket, is because there's safety precautions built into it. There's engineering circuitry and there's hard casing built around the battery to prevent this kind of failure from happening. But all these kind of failures of recalls of batteries all result from the liquid electrolyte in the battery itself. Oh, and there's a picture of our polymer. It's kind of like a saran wrap is the easiest way to think about it. It's flexible, it's thin film, it's actually clear, so it's a little difficult to see up there. Our team consists of me. I'm Erin Fisher. I'm a fourth-year PhD candidate in chemical engineering, Professor Peter Kofinas in bioengineering, and the undergrad Mian Khalid, who's a sophomore bioengineering major. We're actually, because our scientific background is so strong, we're recruiting a CEO and management team to kind of help us with the business end. But we have recruited a number of members to our advisory board, including Dan Janiak, who is an associate at DFJ Mercury, and Brendan Casey, who works at the FDA on biomedical devices. So the instability and the safety issues all result from one component, the liquid electrolyte. And if you're able to remove that component, you can then make a safer battery, which is exactly what our lithium flex technology does. It's a polymer electrolyte, it's an engineered solution, and it has nothing flammable in it. And because it's safer than a normal liquid carbonate solution, you're able to decrease the battery weight, and because it's a polymer, you actually gain in terms of shape flexibility. So what we're able to do by decreasing the weight and the size of the battery, but increasing the safety, we've really got a game-changing technology here that can influence all lithium batteries. Just kind of highlight the problems that batteries had. A number of Fortune 500 companies have had to recall batteries ranging from a couple hundred units all the way up to a few million units. And they've all been because the liquid electrolyte has caused fire problems. And in terms of that, there's also been medical devices, just to kind of highlight, and these recalls have been from Medtronic and Boston Scientific. And if you have to recall an implantable system, not only are you recalling the battery, you're also calling the patient back into surgery. And then in terms of limitations on transportation, the FAA has stepped in and really said you can't transport batteries in an airplane because they're so dangerous. And so you can only bring what you can carry in terms of your cell phone or your laptop and nothing else. But the US battery market really is growing. It's about a $17 billion industry this year, and it's only getting bigger as more people need more mobile power. Just kind of to highlight some of the failures: computers, cars, iPhones, iPads, and then right here, this is actually an implanted, it's a pacemaker that actually failed inside of a patient. And you can see in the bottom right, it actually kind of exploded. And the patient didn't die, thankfully. He just kind of passed out momentarily. They got him to a hospital and had to extricate the pacemaker. But you can see on the picture above it all the dead cells that resulted from it. And that's a pretty nasty thing, and you don't really want to have a failure like that. That's a real PR nightmare. So then looking at the device manufacturers, so they're now trying to prevent this issue, and they usually go to the battery manufacturers who make the batteries and say, I have certain power requirements, certain energy requirements, and certain safety requirements. Sometimes the battery manufacturer can really meet those requirements with an off-the-shelf solution such as this 18650 cell. Just to give you an idea, that's about the size of a AA battery. But sometimes the device manufacturer will be, I need more safety. And so then the battery manufacturer has to turn around to his suppliers who make the electrode materials, the electrolyte, and the other raw materials, and say, I need a safer battery. And this is where our company, SafeLiCell, fits into the supply chain. We provide a solution that can drop in place of liquid electrolytes and still maintain the performance capabilities, but increase the safety. So our technology replaces current state-of-the-art liquid electrolytes with lithium flex electrolyte. And so it's safer, smaller, and you gain in terms of design flexibility, but you don't compromise in terms of performance. And our IP is all protected under patents here at the University of Maryland. And so we have plenty of room to operate without having to license any other technologies related to electrolytes. Now that I've hammered home the point that safe batteries really are a problem, I'm going to talk about the size and the weight. So what you see up here is a wireless endoscopy pill. You swallow this pill, it takes pictures of your GI tract as it goes all the way through, and then it comes out the other side. But number 6 right there, that's actually the battery. And the battery takes up 1/3 of the volume and 1/2 of the weight. So if you can reduce the weight and you reduce the volume, you make this an easier pill to swallow. But there's also another series of devices that really stand to benefit from safer mobile power that's also lighter. And a lot of these are not met by current lithium batteries. Implantable systems, you can't implant a lithium battery because you see the dangers that you're really running up against. Microwave vehicles, so these are small kind of RC copter sized devices that the defense industry is really interested in. And what they allow is they allow you to see around the next corner or over the next hill. But right now the problem is the battery has to be so heavy they actually have to dumb down the sensors on these devices. So if you can make the battery lighter, you can make the RC copter fly longer, and you can also have better sensors on it to make the soldiers smarter. Remote sensory applications, again, they're not met by any real there's no mobile powered battery that can meet the needs that they need for this decentralized kind of power. And then small man submersibles, the Navy's very interested in this. These are 4 to 6 man submersibles, and you can't have the risk of having a fire with 4 to 6 people on board underwater. And so they're very interested in our technology to kind of meet their needs. Comparing our technology to, oh, I just pressed the wrong button. Okay. I guess there's no way. So looking at the liquid electrolyte all the way on the right, as I've said before, the safety of the electrolyte really is the problem. All the recalls have resulted from failure of the liquid electrolyte. And so by replacing that with something that's not combustible, you're kind of looking at 3 options: us and SafeLiCell, SEEO, and SolidCore. The big difference between our technology and SolidCore's technology is it's not rechargeable. So you use it once and you got to get rid of it. And that's a really expensive proposition, and it's really tough if you're going to look at implanting systems into human bodies to kind of call the guy back into surgery because his battery died. And then looking at SEEO's technology, the big difference between our technology and their technology is theirs needs to be at about 115 degrees to operate. And why that's a problem is 115 degrees is if you touch something that's 115 degrees, you'll actually burn yourself. So they're really operating in the region. They have to elevate their temperatures to such a point that now it's not safe to be in contact with it. So our technology really is superior to anything on the market currently, and so that's why we see a lot of growth potential for our company. As a whole, the global battery market is about $75 billion, of which $50 billion is rechargeable batteries and $30 billion is lithium batteries. And this whole pie is growing every year at about 7%. And then the lithium battery is cannibalizing the rechargeable battery market because lithium batteries are the most energy and power dense, and rechargeable batteries because people tend to like things to recharge as opposed to having to discard things every time a battery dies. And so we fit into here, and our technology can apply to all lithium batteries. However, not all batteries, the battery market is not monolithic. The same battery that powers a grid or a car is not the same battery you want powering your cell phone. And so there's different requirements for size, safety, and weight that divide the market up. The most important part in terms of pricing is how much you have to build into safety. Insurance costs and replacement costs are very high, which leads to battery costs being higher than they normally would be. And there's also high barriers to market entry. To convince a manufacturer to switch to your technology, you've got to produce about 1,000 cells showing manufacturing consistency, safety, the safety testing that they want to see, and the performance characteristics. So our market entry strategy begins with the defense sector. We've already have contacts with the Army and the Navy who are very interested in our technology to kind of meet their needs for power solutions that aren't met by anything that they can currently find. And we see ourselves with microwave vehicles, standalone sensory applications, and the small man submersibles I talked about before. In 2016, we envisioned entering the biomedical devices. This lead time is so we can run that 1,000 cycles and test them, and to be able to demonstrate to device manufacturers that switching to lithium flex technology really is the best way to go. And implantable devices, diagnostic probes, and sensors, among many others, really stand to benefit from our technology. By 2019, we envision being able to leverage a kind of economy of scale where we've demonstrated such a track record and we're able to produce a huge number of cells where we can really put ourselves into the cell phone market, the car market, the laptop market, where consumers really recognize that they want a safer battery and they can get it. So here's kind of our financial milestones that we're going to lay out. In 2013, if we raise about $1 million in capital, we're able to enter the defense market. And we've already raised about $2 million in terms of research over the last 8 years to develop this technology. And another $1 million would allow us to develop a pilot plant to kind of get this online to be able to enter the defense market and sell them the technology that they need. And then by 2015, we expect to have positive cash flow. We expect to be able to generate revenue off of our defense contracts because they will be able to recognize that this technology is superior to anything they have. And then by 2016, we'll be able to enter into the medical device markets. And by that point, we start projecting that our revenue will start to double just about every year. And by 2019, we really project to be a very successful, profitable company. Just kind of to summarize again, Lithium Flex is a patent-protected lithium solid polymer electrolyte. And because it's a solid polymer electrolyte, it is safer than anything currently available. And because it's safer, you then end up with a lighter battery, a smaller battery, and you can also pick up in terms of form factor. You can make a battery that no longer is just a brick in the back. It could be the casing of your cell phone. And really the imagination is kind of the limit on how you could design a battery to what it could look like. And then in terms of in performance, you don't compromise by switching to our technology. And the defense and medical devices market really stand to benefit from our technology, and the whole market as a whole of lithium batteries really stands to benefit from using our technology, and there's large growth potential for our company to enter into that $30 billion lithium battery market. Okay. Any questions?
See, now I got it. The question I have is adoption. This is an industrial chemical process, and I've got to imagine, holding aside the FDA side, the near-term consumer markets, but can you walk me through what you know about the adoption cycle for new technologies? I ask because I've got to think that there's a pretty well-defined testing and vetting process. And why don't you walk me through that, and what do they say about your technology?
So if you're asking what the requirements are, there's UL, Underwriters Laboratory, does a lot of this kind of safety testing, and they have a very defined process that you have to go through, from puncture tests where you literally drive a nail through it, you heat it up. There's a lot of series of tests that you have to go through. And basically then they certify your battery, and at that point you're kind of into the general market, and now you're selling to the device manufacturers, and now they're willing to commit to it, because the battery doesn't get approved by itself, it's the whole device. But the device manufacturers don't want to commit to your battery until they know that what the insurance they would have to pay on it, and that's kind of a function of UL and our testing that we do.
Could you give me a successful timeline? Is that months, years?
I would estimate it'd be about a year, probably about 2 years, because the performance testing is really going to be the difficult part. Because if you think about, if you use a battery to simulate actual cycling, if you charge and discharge your battery once a day, kind of like your cell phone, or we'll do it twice a day just to speed it up, and you need to run 500 cycles, you gotta spend 250 days, almost a year, and to run one test. And so those are like the long-term tests that really limit stuff, and that's really what controls how long it takes to enter the market.
So if it takes 2 years, how does that tie to your financials? Where are you now for that ramp?
So entering the defense market functions differently, because these are power applications that you don't have to run through the same kind of safety testing. And we're offering a lighter, smaller battery that meets applications that nothing else can meet right now. And so the defense is really kind of willing to jump in with it. We're not looking at implantable systems with the defense market. And by that point, by 2015, we've spotted ourselves 3 years to kind of get our pilot plant up to scale and get to the point where we've run the testing and gotten the certifications that we would need to convince the medical device market that this would be successful.
One more thought on that. So if someone's building an unmanned vehicle small that you were going to give better battery for, exactly who are you selling to, and how are they getting it in the product? I'm still slightly unclear on that. How that works is, well, the ultimate buyer would be kind of the Army or the Navy or the Air Force. Right.
And they would be the ones buying the battery. But how we manufacture the battery, we work with their contacts. We've worked with contacts at Saft and a couple other manufacturers. And basically what we do is we have to drop our we work on one component, and we can drop our component into the process and replace, they use a polymer film that doesn't do anything, and then they put the liquid in. And replacing their polymer film with our polymer film results in our batteries.
So you're selling to the battery provider now, right?
We're not selling it currently now, but we've talked to them about it, yes.
So you talked about lighter and smaller, which of course everyone's trying to get a lighter and smaller battery that has the same functionality or power output and lifetime. So can you quantify that at all for us? You know, how much lighter, how much smaller? And it seems like you emphasize safety before lighter and smaller. So I'm interested why you went that way.
So safety, how we gain in terms of a weight and size is because we're eliminating the circuitry that prevents overcharging and the fire that you saw, and the casing can be a lot softer. Instead of having like a hard metal casing, you could pretty much put in a Ziploc baggie. And so because you can now eliminate that stuff, which doesn't scale when you go from a big battery to a little battery, they become much bigger elements of size and weight than you gain. And it's because of the safety that we gain in terms of size and weight, and especially on miniature systems. And we kind of estimate that exact number to be a gain in terms of somewhere between 20 and 30%, what we would gain.
20 and 30% on or size or
total? In terms of energy density. Energy and power density. So we can use all the same technologies that the companies are using right now. So we're not requiring them to change anything else.
May I interject? What we are asking them is if they are adopting our solid polymer electrolyte, they won't have to put their heads together for a bulky enclosure or have the protective circuitry. So we eliminate that component in the battery. When we do that, automatically the battery is lighter, and we already know it's safer because our system is intrinsically safe.
So just to be clear, to follow on Phil's point, it's not really a drop in replacement in the sense that in order to get the advantage of your system, you have to design a device to take advantage of not having controllers and all these different aspects.
By drop-in replacement, I'm talking about they do roll-to-roll processing, where they have these huge sheets that unspool, and then they basically push them together, and then they roll it up and they stick it in. And so basically, it's that end step. They can put it into any kind of shape factor, and a lot of those already exist. But instead of putting it in a steel casing, now you could look at kind of putting in a plastic casing, and now you pick up in terms of weight. So the drop-in is more about the roll-to-roll manufacturing they're still able to do.
Basically allows the manufacturer more flexibility in terms of their device design and the battery design.
And so within the lithium-ion market, are manufacturers used to actually outsourcing electrolytes to a third party, or are they internally developing it themselves? The assemblers like Saft, they make no components. They completely are just an assembler. And the electrolytes, all the big companies make really high pure liquid electrolytes, and they just outsource that. Okay, and then you mentioned that defense market, the safety requirements are a lot less. That struck me as a little odd, just because obviously, these are going to unmanned vehicles and whatnot. It's obviously responsible for people's lives. So I imagine the testing and safety requirements are actually pretty large in the defense market versus maybe going to, the consumer electronics market.
I was stressing the difference between an RC copter and a implantable system. Obviously, if I'm going to give this to a soldier to wear, I don't want to just hand him an unsafe technology. But the thing is, we're targeting these applications where they're not met by any lithium battery right now. So we're able to enter in and be the only supplier of a battery that meets their needs right now.
And so why not go into something maybe that doesn't have many safety requirements and issues like the portable electronics market versus going into something like the defense market where it's a lot harder and the safety requirements are probably higher?
So if you're looking at the portable electronics market, you're looking at competing with a number of Chinese and Korean manufacturers who really do this at economies of scale. and they undercut American manufacturers. It takes them about $2 to make a cell in China and Korea. It takes an American somewhere between 5 and 10. And so we don't see being able to enter that market as being very tough. There's also a number of problems where a lot of companies do their batteries in-house. Samsung does their batteries in-house, LG does their batteries in-house. And so to convince them to wholesale change their technologies right up front with the technology we don't have the track record quite yet to convince them to switch to us would be very difficult. Which is why we're working with the defense community, because they really have this need that isn't met by any battery right now.
We got about 30 seconds, so a quick one if somebody has a quick one.
So you're picking fairly price-insensitive industries, military, high-end medical, where you're not in the same competitive cost scale-down situation that you would be in otherwise other industries. So am I to assume that your cost is greatly enhanced? Are you a very expensive product right now compared to the alternatives? I mean, what is your multi-generation product at the price?
So the price we kind of did some rough calculations, and we target that our battery would cost about $3 more. But that's just material costs. But you gain in terms of insurance costs, recall costs, and so that's where we kind of see the price point. And that's why we recognize that entering into those kind of markets would be a little safer for us to get our feet under our ground and become a profitable company before entering into the more competitive general battery market.
Yeah, sorry, we're going to cut you off. We keep on getting cut off on the cost questions for some reason. Nice job, guys.
Thanks.
Thanks.
Thank you very much.
All right, let's give a hand to SafeLiCell from Maryland.